Chapter 18. Create review and coordination process to increase quality of our current work by Group 4, Zach Allen, Chandler Foster, and Ron Silva. In this chapter, we will talk about the danger of change approval process, potential dangers of overlay control changes, enable coordination and scheduling of change, enable peer review of change, potential dangers of doing more manual testing and change freezers, enable pair programming to improve all our changes, evaluating the effectiveness of pull request process, fairly good bureaucratic process. So in this chapter we will review how developer and operation can reduce the risk when making changes in production using a great tool such as GitHub. GitHub this will allow us to have a better system, safe and without fails when including the entire work team in this process. GitHub is a great application that allows us to review each step of our application and allow us to share the work with other people who also work in the same application or inspect the application to avoid any error. Once we have a change in the application, we pull in GitHub repository and we allow to the other part of the group to see these changes. You can also write comments and make other changes. The pull request is the mechanism that help us to deploy the code into production through collaboration of the team. To achieve this, we must follow 5 steps that we call the GitHub flow. So on this part of the steps, the number 1 is when we work, when we have a new project, we create a name, a descriptive name of the master. There we commit the branch locally, regularly pushing the word to the same name branch of the server. When we need a feedback or help, or when they think that the branch is ready to merge in, they open a pull request. When they get the desired review and get the necessary approval to the filter, then the people can then merge into the master. When the code change are merged and pushed to the master, the people deploy them into production. So with this tool, with GitHub, we can work on in our application and make sure all the changes that the people can see all the changes, and we can review all the application. So we're going to talk about the danger of changes approval process. A great example of danger of changes approval process happened to the financial service company Knight Capital Group. It took only one defect in a trading software deployment for Knight Capital to lose $440 million in about 15 minutes. The incident happened after the technician forgot to copy a new code to one of the Ada smart computer servers. This type of error can happen in any type of application in any company. And making change, we have the risk that something bad can happen or that we forget a step. It is important to have a good control of the changes that are made in the application in order to have a better management of the risks that may exist. In addition, you have to have a good testing practice to identify early any risk that our application may have. Potential dangers of overly controlled change. When error occurs, is there where we ask ourselves what is wrong or what we need to do so that error doesn't happen again. Some measure we can take is adding more questions that need to answer to the changes request form, or require more authorization, like have another manager do the authorization, the approval. Uh, Also request more lead time for changes approval, so that change request can be high quality. Uh, Although these changes, these measures are not always going to be the best for the team. Uh, we need to create effective control practice that more closely resemble peer review, reducing our reliance or on external bodies to authorize our changes. We also need to coordinate and schedule changes effectively.
Enable coordination and scheduling of changes. When multiple groups share dependencies, changes need to be coordinated. This is so that more than one change isn't made at the same time and you end up overriding something. So the more loosely coupled the architecture is, the less communication will be required. And that's because you'll be less likely to change something that affects someone else's code. Code interferences are still possible, even if it's lightly coupled. So it can be a good idea to use chat rooms to communicate with the others working on the project. That way you can just be sure that you don't override anybody else's changes and you don't cause any errors. And for more tightly coupled architectures, change scheduling might still be required. It can be a good idea to schedule your changes ahead of time so people know that you're going to be putting changes through and you don't cause any problems. Enable peer review of changes. So peer reviews can be used to find errors in your code, and a good place to use or to require the peer review is before committing the code to the trunk. And this is just so you can be sure that the code is good before it's pushed in and committed to the rest of the code, the project. So larger code is more difficult to peer review. If you have a code that's like 1,000 lines, it can be much easier for the person to miss things and just be lazy with it and say, oh, it's fine. Whereas a smaller code, they're more likely to look over in detail and catch any of the minor errors that may be in the code. So it's a good practice to work with smaller amounts of code at a time. And the common forms of peer review include pair programming, over the shoulder, email pass around, and tool assisted code review. Potential dangers of doing more manual testing and change freezes. So doing too much testing can actually worsen the outcomes of your code. It can cause batch sizes to build up because things are stuck in testing for too long. There's just a lot of errors that can happen because of it. It's especially true when you're doing manual testing because manual tests can take so much time, and that's what can cause batch sizes to build up and be way larger than they should be. Also with manual testing, you can never be sure that you're doing the test the same way every time, and that can cause small errors as well. So in order to remedy or resolve this, you want to fully integrate testing into the daily work. That way, code's tested all the time, and you can always be sure that the same tests are being ran and things will be consistent.
Pair programming is a method of work where two engineers work together at the same workstation. This technique can be used by anyone in the value stream, not just developers. Although because of the word programming, it does usually refer to developers, so we'll focus on that. There are two common patterns of pairing. In the first method, one engineer acts as a driver. The role of the driver is to write the actual code. The other engineer acts as the navigator or observer. The role of the navigator is to review the code that's being written in real time. This gives immediate feedback to the driver engineer and allows him or her to focus on solving the task at hand. The observer can make suggestions and corrections as they work together. The second method is good for situations where test-driven development is in place. One engineer writes unit tests while the second engineer writes the code. Pair programming, while not always popular, has some real advantages. The most obvious is the immediate feedback that the developer receives while writing the code. Any potential issues or errors can be resolved quickly. Because both engineers are working together, there is a level of communication that must be achieved to be successful. This communication facilitates knowledge transfer between both engineers, thereby providing a mechanism of learning. And ultimately, there will be fewer defects passed along. A study by Dr. Laurie Williams in 2001 showed that paired programmers are 15% slower than an individual engineer working alone, but it also revealed that the amount of error-free code increased from 70 to 85%. One way to evaluate whether or not our peer reviews are working is to analyze production outages and how they correlate with the peer review processes. Another method is to evaluate the effectiveness of our pull request processes. Ryan Tomeko, CIO and co-founder of GitHub, described the differences between a bad pull request and a good one. One example he gave of a bad request was one that contained only the words, quote, fixing issue number 3616 and number 3841, end quote, and nothing else. He explained that bad requests are those that have no context for how the request works or how it fixes an issue. Other attributes of a bad pull request are those that contain little or no documentation, those which make no mention of mentors or subject matter experts, or those that don't even contain so much as an explanation of why the request is needed. In contrast, a good pull request contains detailed documentation on why or how the changes were made. They identify risks associated with the changes and any resulting countermeasures. Oftentimes, a pull request will result in discussions between multiple engineers. When these discussions are constructive, instead of blaming when issues arise, it can be a positive thing, and therefore it can still be considered a good pull request. Traditionally, many organizations try to manage the quality of work through various approval processes. Unfortunately, these processes tend to increase lead times, which can cause risk or lower customer satisfaction. As we evaluate these processes, we should be willing to re-engineer them if we see that they are having a negative effect or if they are too constrictive. One way to do this is to correlate our work tickets with any corresponding meetings. We should consider reducing or eliminating them. Some companies have formed teams with the specific objective of removing obstacles that slow or impede our daily work. As of 2012, Target had an approval process in place called the Technology Enterprise Adoption Process and Lead Architecture Review Board, also known as TEAP-LARB. All new features had to go through this process and would be reviewed in monthly LARB meetings for approval. The process was long, and when Heather Mickman and Ross Clanton led the DevOps initiative at Target, they had identified a specific technology that would be useful for the company. As it went through the LARB process, it was decided that it could not be supported by operations, so it was denied. Mickman was persistent and proposed that her team would be completely responsible for all aspects from development to support and security. Through this process, questions arose about why the TEAP-LARB process even existed in the first place. No one seemed to know, other than that it may have stemmed from some issue that had occurred many years before. It was determined that the process was no longer needed and it was eliminated. This is a good example of being fearless in cutting the red tape of bureaucracy from our processes. In this presentation, we have learned about the importance of creating review and coordination processes to increase the quality of our current work. We've learned about change approval processes and that in a low-trust environment, there is a danger that they can actually increase the likelihood that problems will occur. We've learned that these approval processes can often lead to other unintended outcomes, such as long lead times. We've learned that changes need to be coordinated, especially when multiple groups share dependencies. We've discussed creating a culture of peer review where we have a team mentality for quality. We've learned that manual testing can be time-consuming and error-prone, and that it's better to integrate automated testing into our daily work. We've explored 2 methods of paired programming to achieve better outcomes and learning. We learned the differences between good and bad pull requests, and that even when the outcome of a request isn't what was intended, it can still be a good pull request because of the information and discussion achieved. Finally, we discussed the need to cut the red tape of bureaucratic processes that could be impeding our work. We hope you enjoyed our presentation. Do you have any questions?